Hello everyone and welcome to this Telit-sponsored webinar. I'm Robin Duke-Woolley, CEO at Beecham Research, which is a specialist IoT advisory firm operating worldwide. I'm the moderator for this somewhat unusual event, which is a follow-up to our webinar held in December. Over the next 30 to 40 minutes, we're going to address some of the questions we received in the original GSMA Private LTE Networking and Enterprise IoT webinar we hosted on December the 12th. In that webinar, we had over 700 registrants, but more importantly, over 100 audience questions. So there was little time to address all of those questions in the time we had available. To listen to the original GSMA What You Need to Know About Private LTE Networking and Enterprise IoT webinar, which you can access in the Resources tab and on their website in the Resources section. In addition, also in the Resources tab, you can chat with a private LTE specialist at Telit and to request a private LTE sample. And there are tabs for those, for accessing those in the Resources section. To get into the detail, I'm delighted to be joined by Safi Khan, a Regional Product Manager, Marketing Director at Telit, who was the other speaker at the webinar. Hello, Safi.
Hello, everyone.
Great. So these are the main topics, and private networking is trending as large companies are finding out they need to offer a more secure, scalable, and resilient solution compared to traditional Wi-Fi connectivity for IoT applications. Costs associated with the high data transfer volume over public LTE make private LTE more amenable, especially when Wi-Fi coverage throughout the enterprise campus is at or above the standards capabilities. For this webinar, we've broken down the 100 questions from the original webinar into the 9 categories you can see, and we're going to address those today. So Safi and I will be sharing these. If there are further questions arising in this session, we'll get back to you afterwards with our responses. So this session will be primarily to respond to questions we've already had, trying to get to grips with those. So we'll see how we get on. So the first section is on the market, which is my area. Now, I would say that, not to spoil things, but I would say that we are just at the point of releasing a new report in this area. So when it comes down to the detail of CAGR and growth rates and so forth, those are aspects of our report. So you'll understand that we would feel that we're selling the gold rather cheap if we give too much away in this webinar. But we can give indications of how things are moving. So I used the next slide as a way of showing how the market overall is moving, and then how that reflects on the LTE market, or the private LTE market. The cellular IoT market growth is like this. It's about a billion connections, cellular connections by this year, and then rising to 4 billion by 2025. The huge growth is due to a large increase in what we expect at the low band end, NB-IoT and LTE-M. At the same time, we expect legacy 2G and 3G to tail off, and high bandwidth also to grow quickly. When it comes to different regions, we're anticipating North America is one of the highest growth areas, particularly for private LTE over the next 5 years. we have it as the largest market, compared with the second largest being APAC and the third largest being Western Europe. So we anticipate strong growth in the US market, and that's partly because of CBRS and the introduction of that. That offers new opportunities for smaller companies. Private LTE has always been primarily a big company operation, because there's been a need to buy or share spectrum to be able to deploy a private LTE network. But if you can do that with unlicensed bands, then that cost is diminished. Now, obviously, CBRS is primarily at the moment looking at broadband and high bandwidth applications, so that will tend to move it towards particular applications rather than others, and we'll get onto that in a minute. So the growth rate, we think, overall for private LTE is pretty high. We think that it will be higher than the overall CAGR of cellular IoT, which is just over 30% per annum. And in the North American market, it'll be above average, and in other markets like Africa, for example, it'll be below average. So I hope that gives some sort of response to that sort of question. Just going back to the questions. I think that probably answers most of what I think I can answer at the moment. The opportunities for emerging markets, I think, is really something that we can address in the next series of questions, which is about industries. So some of those questions: what are the key applications for private LTE networks? What are the key benefits, both technical and commercial ones, for enterprises to deploy private LTE networks compared to public LTE, Wi-Fi, etc. How are these capabilities being deployed in a commercial setting, offices, schools, etc. How is IoT applied in real facilities management or building automation, in providing alerts, door open, close, asset movement and staff movement, tracking in a building? That's quite a detailed question. It also tends to be more low band rather than high band, so probably not something that we would address here. IoT, of course, is used extensively in facilities management, and always has been. It's really an extension of monitoring. So large numbers of connections all over the building, all sort of sensor-based, and leading into probably a platform of some sort that then provides the control for the building. But we showed in the webinar these are the most likely areas where private LTE is going to be or is popular. So mining at one end, oil and gas, military bases, power generation, all the way up to warehouses and industrial and manufacturing. In fact, if you take warehouses and industrial and manufacturing, those two alone represent roughly 70% of the available sites worldwide. But they're not necessarily the most profitable sites. So they might not be the largest sites. For example, lots of warehouses are relatively small, and therefore don't have a significant implementation. And indeed, that's the case for industrial and manufacturing. But nevertheless, when you look at the categories, those are the sites that represent the largest numbers. when you look at the opportunities for individual sites, then you're looking at then you're looking at a variety of different areas, and it's really the large sites which are dispersed that are finding great favour at the moment. So, for example, a container port that needs to have good coverage across the site, and maybe a large site. If the traditional way of doing that is using Wi-Fi, then that is being found to be limiting. And I will talk about Wi-Fi and its limitations a little later. But that is now finding favour with private LTE, and moving that forward means that it's possible to have a larger coverage, a better coverage with less access points, and therefore can potentially be cheaper, and certainly has some benefits in terms of congestion coverage and so forth. So there are some significant benefits associated with private LTE versus Wi-Fi in very large sites, and that's something that is clearly going to accelerate over the next few years. Now, we anticipate that in most markets, the broadband area will tend to accelerate first, because that's got a higher return rate, and there is a bigger requirement for that compared with Wi-Fi use. So we're not saying that private LTE will replace Wi-Fi. What we're saying is that private LTE will complement Wi-Fi. Wi-Fi is perhaps more relevant for business operations, administrative operations. It's less suitable for IoT operations, particularly intensive IoT operations. But as I say, we'll get to that when we cover Wi-Fi in more depth. So shopping malls, airports. Unfortunately, we put a port instead of an airport in the picture. Warehouses, but also theme parks. So you can imagine a theme park that has a number of different hubs. It might have several different restaurants, security posts, and so forth, and they all have a series of operations associated with them. So that restaurant has say 5 or 6, maybe more, devices associated with it that all need to be connected, and they would then be connected through to a gateway that then uses a private LTE broadband link, and that could be CBRS, to take it back to a central control point. That represents a real step forward in terms of cost-effective deployment of the technology to get the sort of responses that are needed for the management of those functions. So you can see that there could be 10 or 20 such, or even more perhaps, hubs within one theme park, and therefore there's quite a substantial volume of those within one installation. Now that for the gateway suppliers actually is very good news, because the tendency is that gateways are sold in relatively small numbers across large numbers of sites. This is the opposite. This is a large number of gateways over a smaller number of sites. So it represents a new market opportunity for gateways, and we are anticipating a huge growth in the gateway market opportunity over the next few years due to the introduction of private networking, and in this case, in the US market, CBRS in particular. So that's probably as much as I can say on those. I'm now going to hand over to one more thing here. Sorry, on this slide here, industry analysis, which is one of Safi's slides, so he might want to add to this. This represents where the digitization, the extent of digitization, is happening at the moment, and the number of networks delivered by 2023. And what he's got is that for manufacturing, logistics and supply, warehousing, and public enterprise venues, the number of networks delivered is high, and then down to low for public safety. This reflects the number of such sites available in the marketplace. As I was saying earlier, warehousing and manufacturing represent roughly 70% of the available sites. So there's a lot of effort going into looking to see how private LTE can cover those. One thing I would say, which I didn't say in my last slide, is when it comes to size of company, as I said earlier, private LTE has always been a large company thing, but the introduction of unlicensed introduces the opportunity for smaller companies to participate in the private LTE market, and we expect that to accelerate because one of the surveys that we run, which is reported on in our report, shows that there is actually quite a substantial pent-up demand for private LTE at reasonable prices among smaller companies. It's partly to do with Wi-Fi, but not entirely to do with Wi-Fi. Safi, I don't know if you want to add anything to that.
No, I think you did a great job, Robin. Thanks.
Okay, all right. In that case, I'll pass over to Safi, who's going to talk about spectrum and bands.
Thank you, Robin. Okay, so switching gears a little bit, among the many questions that we received, a lot of the curiosity is around the actual spectrum that we are talking about here. And so, as you can see from this list of questions, it ranges from, what is it like Wi-Fi? Is it the same frequency as Wi-Fi? To what will be the cost of this spectrum? And do you have to go get service from one of the telecom operators, or can you operate this by yourself? So I will try to address all these questions, hopefully to the audience's satisfaction. And let me advance to this slide here. Okay, so let me just repeat a few details that we already covered in the webinar, but just as a refresher for the audience as to what is the private LTE and private 5G spectrum that we are talking about. So the most common terminology that you will hear for private networks is band 48, and you will also hear band 42 and band 43. So the picture on the left is showing band 42 and 43 in their full extent. And so as you can see, band 48 straddles band 42 and 43. So in the US, North America, the CBRS on-go service is the band 48, which is 3.55 gigahertz to 3.7 gigahertz. But as you can see, band 42 and 43 are wider than band 48, but they do overlap. So you can think of it this way. Band 48 is for North America primarily, whereas Band 42 and 43 are used in other regions like Europe primarily, and APAC, and Australia and LATAM. So these Band 42 and 43 are what would be the private LTE version in other countries other than the U.S. And when it comes to the U.S., obviously the CBRS Alliance with the on-go service in Band 48 is leading the private LTE wave. Now, on the top right is the drill down into the Band 48 CBRS particularly. So there are three classes of tiers that are defined. And so the tier 1 on the bottom is the incumbent. So that basically means that the wireless internet service providers, the fixed satellite stations, and the U.S. military radars, primarily the Navy radars, they already operate in this frequency, but the government of the United States and FCC mandated to open this spectrum up for use by the public using a scheme in which the Tier 2 priority access licenses are licenses that will be auctioned similar to any other spectrum under the FCC. And then the entire 150 megahertz is also available for anyone who doesn't need to get a license. And as long as a PAL is not operating, and as long as the Navy is not operating, and the WISPs and the FSS is not operating, then the general access, authorized access user can use the spectrum. So it is this lower cost and availability of spectrum which is very lucrative and attractive to the companies. So the questions that were received, I'll try to address them in a few words on what is happening in terms of how this network will be managed. So the FCC will auction the PAL licenses in June of 2020, which is basically 5 months away. And they're giving away 70 megahertz total, which is that red bar shown in the diagram. Now, there is strong interest from mobile network operators, as well as the smaller players like cable companies who want to add wireless service, as well as real estate developers, big companies that go in and develop stadiums or large venues like concert halls. They want to provide this service, so they want to bid for this license. So we will see how this license auction turns out to figure out the cost of using this. Another big announcement that happened is that 3GPP cleared the way for Band 48 to be used for 5G, and it's called N48, and I will cover that in a future slide, so I'll skip that for now. And then there were couple of questions on narrowband technologies. So those are not yet ready for CBRS Band 48. None of the chipsets support that today, and also 3GPP has not cleared the way for these narrowband technologies to be deployed in this spectrum yet. So just to address some of those questions, how is interference managed, and how do you obtain the spectrum, etc. So the CBRS on-go system already provides mechanisms for managing interference from other service providers. As I said, the 70 megahertz of spectrum is going to be licensed in chunks of 10 megahertz pieces, and one operator or one entity can get up to 4 10 megahertz chunks. So they can get up to 40 megahertz, and it doesn't have to be contiguous. So it will be randomly assigned at the auction. So it means that the general authorized access user will be able to operate as long as the PAL user is not operating and the incumbents are not operating. And all of that is managed by this entity called the SAS, which is the Spectrum Access System. So again, I would refer you to go, if you haven't, to listen to our other webinar to know the details of how the SAS operates. Now, an independent private LTE player doesn't have to be dependent on the telecom operators. If they won a PAL license, they can operate the service themselves. This is the beauty of private LTE networks, that they do not depend on the licensed spectrum of the telecom operator. But what may happen in the U.S., for example, is that these same telecom operators, which we know, the big four in the U.S., for example, they will heavily bid on the PAL licenses because they want to get more capacity and more offload, and they can do a carrier aggregation. So they can actually use this spectrum for their existing service and enhance it if they can win the PAL licenses. So again, the stage is set for the auction starting in June, and we're going to keep an eye on what happens. And that will also determine the cost of this spectrum on how much someone can charge a user. But it is going to be more economical than the prime other licensed spectrum where it's exclusive use. So the difference between that and this is that the GAA users can come and also use the spectrum. So I think that's how much I want to say on this topic of spectrum and band. And if you have questions, you can send us and we will address them offline. So now let's move on to another category of questions that we received. Now, these questions are related more on deployment and management. So we're getting a little more deeper involved into the how the network actually operates. So again, these questions are covering a wide spectrum. What is the process of deploying a private LTE network? Do you require a SIM card? How do you authenticate? And what is the end-to-end business and operational perspective about private LTE and 5G, etc. So for this, what I will do is I will again cover some of the architectural concepts at a high level to try to address these questions. Right. So there are many ways in which the private networks will be managed and deployed. The most common themes are shown here on the right. The one on the top is what we call a self-contained private LTE network, and it can be for a particular venue. I think Robin already alluded to this, transportation venue like an airport. So this can also be an industrial setting, logistics hub for transport, sports stadium, concert venue, or just an enterprise setting like an office that needs to provide internet service like broadband. And so we are seeing the strong demand for private LTE networks in all these scenarios. So this is something that you can deploy in a private setting, but it's a 3GPP cellular deployment, whereas previously there may be a Wi-Fi network operating in this venue. The second option on the bottom right is another option which the CBIS Alliance has developed, which is called a neutral host setting. And now here an entity can basically be a neutral host for a venue, put up a full private LTE network, and then offer it as additional coverage, like, for example, indoor coverage or enhanced coverage for both public networks as well as other private networks. So this neutral host entity can basically do onboarding. It can have most of the devices have a dual SIM, so you could roam you could mostly stay on the private LTE network when you are in coverage, and when you leave this area, you switch back to your public network. So the deployment, there are many companies, for example, in the construction space, who go and provide connectivity to these venues like stadiums, etc. And they will sometimes deploy their own private network themselves, or they might partner with another company, for example, like a system integrator that's providing the DAS service, distributed antenna service, and become a neutral entity that provides service. So there are many options for deployment and management. It's a 3GPP network, so let me also kind of shed some light on a little more technical aspect, just because the type of questions we received from the audience seemed more technical. So this basically what I'm showing here is a more detailed and technical diagram. So as I said, we received multiple questions on how a private LTE network is deployed and managed, how do the SIMs operate, etc. So to address that, I've put here the architectural diagram of a CBRS on-go private network architecture. And this is a bit technical, so I will not go into each detail, but the few points I want to mention here is that the CBRS Alliance has a technical working group which is working on these types of issues that have come up, just like the questions that we received. And they're working on formal releases to define the CBRS service. They're currently busy working on Release 4, so they've already worked on 3 releases. Release 4 is focusing on adding 5G, among other topics, to the CBRS on-go service. As you can see here, like if you are familiar with the network architecture of LTE as defined in the 3GPP standard, most of the components here are directly similar to the 3GPP LTE network components. These are things like, packet gateways, the eNode B, which is like the base station, the ePDGs, the AAA authentication server, SIM, USIM, etc. So this network is by all means an LTE network. The only difference is that the spectrum the owner of the spectrum who's operating it, it's not like a large public operator like the Big Four in the US. It is a smaller entity, so it's basically a miniature version of a macro network. You can imagine that way. So it's a very similar to a public LTE network, except that the SIM and the subscriber and the network identity, all the identification of the subscriber and the network itself is managed under the CBRS Alliance on-go service and certification, and combined with the particular service provider entity, which is offering the network as a service. And so all those components and the questions that have been asked are already answered in the releases, the detailed technical working group releases. So if you are someone who is very interested in this, you can join the CBRS Alliance and get access to all the technical collateral that has been developed and learn how this network operates. They do have very good YouTube webinars publicly available. So there's CBRS Alliance, and then also there is the WIN Forum, which is Wireless Internet Forum. So those two entities are very useful. And they do all the management of the SIMs as well as the network. So hopefully that answers some of the deployment and management questions. And then I'll hand it back to Robin for the next topic.
That's great, Safi. Thanks very much. So I'm going to talk a bit more about Wi-Fi, which I mentioned earlier. Will Wi-Fi compare with low latency private 5G networks? Why enterprises will choose LTE over Wi-Fi? So questions like that came up, and we didn't have a great deal of time to address those. I showed a slide. I showed two, actually. First of all, this one, which shows that on-site use of connectivity technologies is high. This came from our own survey of enterprise users, and it shows that Wi-Fi use on private networking is very high at the moment. 86% of the survey respondents with cellular some way behind. Bluetooth got in the mix there somewhere, not entirely relevant. LoRa and Sigfox in there as well. So that shows the high usage of Wi-Fi at the moment, and it's primarily because there isn't an option. It's what people have available to use. But there are significant limitations in using Wi-Fi when it comes to IoT applications. So, for example, does the application need to operate outdoors? 59% said yes. If so, does that present difficulties in use of Wi-Fi? 56% of those 59% said yes. Does it need to connect with moving vehicles? 63% said yes, of which 94% said if so, does it sometimes lose the connection? So as I say, 94% said yes, it does. So even just with those two activities, it's pretty clear that Wi-Fi is not ideal. And Wi-Fi 6 doesn't really change that. Wi-Fi 6 increases the capacity. What it doesn't do is really change the ability to move, to roam, and to operate outdoors. So we don't see it changing that much, and we don't think that the Wi-Fi Alliance does either. We think the situation with Wi-Fi is that it's going off in a direction that supports obviously home, but increasingly business-related activities in offices, and is not really targeting increasing use of IoT. And as IoT gets more important to operations, as operations become like more mission critical, more real time, it's becoming much more important that there is coverage for those, because it represents real revenue if data is lost. So an answer has to be found that is better than current Wi-Fi, and CBRS as part of private LTE is a significant step forward in that, and therefore a significant potential opportunity to move the market forward. As I said earlier, we found that there is something of a pent-up demand for private LTE among smaller companies. It's just they can't afford it. So if they were able to do so, that market would be probably substantially larger, which means that the enterprise IoT market is effectively being held back because of lack of availability of private LTE. I mean, it's not to say it's being held back is probably unfair, because it's a new activity, and it's something that has grown up over the last couple of years or so as being significant and more important. But it is clear that it is a direction that warrants further investigation to free up spectrum to make private LTE more available for smaller companies. So that's probably the main thing that I was going to say there. So I'm going to hand over back to Safi, who's going to talk about 4G and LTE failover.
Okay, thanks, Robin. Okay, great. So this is another category of questions that we received in terms of what happens, let's say, when you walk away from a private LTE network coverage. How do you fail over? Or the other way around, where you have a fixed public network available, but you also need to enhance it with a private network for more flexibility, etc. And so let me put up this slide again. This is from the CBRS Alliance on Go to address exactly these kind of questions. So what's being shown here is, what is the current solution and approach, and what are the limitations, right? So today you have multiple networks and service providers, you use Wi-Fi, and it has some security issues, which we will cover later, and also privacy problems. And of course, you also have the terrestrial cables operations, but they also have they get impacted by the lack of flexibility. And so you're left with, let's say, a single network technology, and you don't have a redundancy or secure way to failover, when that service goes dark. So the OnGo is trying to address those by having the private network as a redundant secondary network with a reduced total cost of operations because of the spectrum being more economical. And it's leveraging the LTE ecosystem, which means the devices, the price of the products is already reduced because of the economy of scale of the LTE deployments worldwide. And now you have a single network for multiple use cases. And so these are, again, listed here in the middle, which is it can support the high data rate use cases that we already mentioned. So broadband, fixed wireless access is the main use case out the gate for OnGo. But it also allows for flexibility to make network changes. Now, because you are the owner of a private network, you can actually put up more eNode Bs to enhance a coverage, or you can reduce them if you have too many. So this is not something you have available when you are dealing with a network operator. They choose where to deploy, where it makes most economic sense for them, which may not be the best for you. For example, a good example is indoor coverage. Many times I have suffered, and you might have suffered, like if you're in an underground parking garage, you will definitely lose your voice call or your data on your phone. So this is where a private OnGo service can make sure that all the underground as well as indoor are fully covered with LTE coverage. And so that's basically like a failover in the other direction, where you have service with an operator, but once you are inside a particular venue and you're losing the coverage from that operator, then you can failover and switch to the OnGo service. CBRS Alliance has also done multiple studies to compare the cost of operating a private network. They compared it against Wi-Fi as well as compared it to public networks. So it is expected that the total cost of private networks is lower than Wi-Fi, meaning you have to put up less number of access points, as an example, and the coverage is better, so you have lower cost. As well as compared to public cellular networks. Although this will become more clear later this year after the auction. So again, let's reserve final comments until we know how much demand there is for that spectrum. It may also get bid very high, or it may not get bid very high. We will see. And that will start in June. And so hopefully this covers the questions received regarding failover. As you can see, it is being thought through in the working groups within the Alliance. And so OnGo is a path towards a redundant and secondary network for failover. Okay, so let's see what's the next section. I think it is also mine. Yes. Okay, great. So now let's transition into what's happening with 5G. So a lot of interest in terms of questions received, as you can see. And so we do understand this interest. And I already mentioned the band 48 becoming N48, which is the nomenclature for whenever there's a 5G new radio band, NR. The band is prefixed with the letter N to designate it as a band for 5G. And so let me just say that, yes, now 5G is a technology that's fully approved by 3GPP to operate in band 48. So this is good news. But I think some of the questions here, I would address them by saying that it is very good that 5G is a viable technology for Band 48, but it is further away in time, so you have to wait for it. Now, by that, what I mean is the benefits of the vertical, especially the manufacturing and industrial, that requires the ultra-low latency, will happen at least 2 or 3 years later when the next release of 5G is finalized by 3GPP and the ecosystem is ready. But it will be a very good transition at that time. So the question that the big theme here is, should I wait for 5G or go with private LTE? So my assessment here is that 5G is further away. So if you can wait 2 or 3 years, yes, you can wait. But LTE today already allows the broadband and the fixed wireless access use case. So again, I think it depends on your particular need. If you are looking for like indoor coverage, enhanced connectivity, all those reasons we've already covered, then I think there's no reason to wait for 5G. You can start with private LTE. As far as the question about whether you can upgrade to 5G through software, that is a good question. And it depends on which component of the network you're talking about. On the UE side, which is the end user device, it is difficult to put in a 5G radio just for future proofing it, and the existing LTE does not do 5G operations. So you will have to upgrade those devices to 5G devices when they are available. And on the infrastructure side, I believe that most of those products are software driven, and so they would probably be able to upgrade to 5G with software updates, mainly because this is a sub-6 deployment. It's not millimeter wave. And in sub-6, there are LTE bands that might already be covering band 48. And so upgrading to 5G may be a software change in the network side. I just want to provide a couple of quotes from FCC and the chairman, just to show you how much strategically 5G means to the industry. So here it says, for example, a report in 2018 says that since the Commission established service rules for the 3.5 to 3.7 gigahertz band, it has become clear that the band will be an essential part of 5G throughout the world. So they envision 5G to be used in mid-band. And then from the FCC chairman Pai, he said in September of last year, so only a few months ago, like the 2.5 gigahertz band, the 3.5 gigahertz band is prime mid-band spectrum that holds particular promise for 5G. We didn't have the right rules in place to encourage 5G. Those reforms have made 3.5 gigahertz licenses much more appealing for 5G operations. So just remember that this is just paving the way for 5G, and there is a C-band spectrum on the table which will be coming up, and FCC will open up additional spectrum above band 48, and so that's really the main. This will pave the way for having a much bigger chunk of spectrum available for mid-band 5G. So I hope that this addresses the questions on 5G in like private 5G space.
Right.
Okay, so
Great.
Back to you, Robin.
Okay, yes, great. Very interesting quotes there. I think I haven't seen those before, so very helpful. Okay, so I'm going to talk a little bit about CBRS, but actually I'm going to bring Safi in on this as well. because one of the questions at least is, do you know if device manufacturers, tablets, barcode readers, etc., will produce CBRS-compatible devices? I think as a module supplier, Telit has a good feel for what is happening in that market. So I'm going to bring him in on that. And then there is another question which I think is becoming relevant, actually, which is what's the impact of decisions to use band 48? Since you've been talking about that for the last few minutes, I think that we can probably ignore that one. So I think if I could just ask you, Safi, about this device manufacturers, tablets, what do you think that is likely to happen there? It seems to me that if they can see value, then they will do that. So we'll get probably some manufacturers will do that and others won't. But your view is more solid than mine, I think.
So I think the answer, the short answer is yes. So with everything, I think what happens is in the industry, we are all familiar with it, that in mobile and wireless, the whole industry is basically led and driven by the mobile space. So smartphone and tablet drive the industry, primarily putting new features and bringing out new features. So today, most top-tier smartphones already support 2 SIMs and band 48. So it means they are already ready for private networks. Now, along the same ecosystem, when the same device manufacturers have tablet variants as well as, so the barcode reader could be like an IoT device that you can imagine. So the same demand, now that the network is there and the device ecosystem is there, it's very easy for them to deploy the same chipsets into other product categories. So the answer is yes, tablets and laptops, as well as barcode readers and other many gateways, routers, or other end-user devices, they all have the support for band 48, and they can deploy the SIM solution in these to make them a private network-ready devices. We are seeing that demand from our modules as well.
That's great. Okay. I'm going to cut this a little short because this has taken substantially longer to get here than I'd anticipated. I thought we were going to be 40 minutes, but we're already at 53. So one further question. Do you see private LTE in competition with 5G when use of private LTE and when 5G is available everywhere? I think Safi has really spoken to that as well. If you can afford to wait, then wait, but 5G is not imminent. And 5G for IoT and 5G for IoT network slicing is certainly not imminent. The emphasis on 5G at the moment is on consumer handsets and the introduction of those. So the features surrounding those are going to be implemented first. So we can see 5G in IoT as an evolution from private LTE or from LTE, and it may not be a complete solution either. So sometimes it will be, and sometimes it might not be. So it depends on what the particular circumstances are. It all adds to the choice available and means that there will be significantly more choice available than there has been up to now, and that's a good thing. So although we worry about the fact that it's not a clear answer, actually that's a good thing because it depends what the particular circumstances are, and there are some technologies, there are some solutions that are more appropriate for some approaches than others. So I think if you keep that kind of perspective in mind, that's a useful perspective to have. I'm going to move on now because we need to cover security, and that might take a couple of minutes. I was going to say something about multi-fire, but I won't.
Great. So
over to you, Safi, on security.
Good. So again, this is a very, very important topic in today's age. And the couple of questions here is what type of security solutions are in private networks? Does a security solution make sense for every IoT device? And so, and similarly, the other one. So I think what I would say here is the biggest benefit here is that it's more secure than Wi-Fi, right? So in your mind, when you have networks with wireless connectivity for IoT devices, we have seen many cases where because Wi-Fi is so prevalent and open uses unlicensed spectrum, Wi-Fi hacking is now very easy. There are actually, industries and applications that people thrive on to give them to users to make the hacking easy. It's become a hobby and it's become a business to go sniff the Wi-Fi networks and then hack them and steal people's credentials. Now, when we talk, on the other hand, about enterprise-level security, so an LTE cellular network is built from the ground up with enterprise security as front and center. It's end-to-end encryption as well as enterprise-level security. So it's much more secure than Wi-Fi, and it's much more difficult to hack compared to Wi-Fi. So the incentive is for the hacker to go attack Wi-Fi rather than cellular. And another important point to make regarding security is that in a private network, you have all your network components on premises. So all your sensitive data stays on premises. You may have a control plane, maybe a cloud interface to control the network, but the actual data stays on premises, which is very important for the types of industry verticals that we have been talking about, airports, logistics, venues, important enterprise. So this is why I think security is naturally goes hand in hand with private networks, especially compared to Wi-Fi.
Very good. Okay. Well, we're going to wrap up there because actually we're pretty much out of time. Thank you all very much for taking part in today's webinar. A replay will be available shortly, so if you missed any of the content, you'll be able to catch up. I'd also like to remind the audience again to listen to the original What You Need to Know About Private LTE Networking and Enterprise IoT webinar, which you can access in the Resources tab, along with the other resources I mentioned earlier, chatting with a private LTE specialist or requesting a private LTE sample. Thanks again, Safi, and thanks to our audience for taking part. We will see you again very soon. Goodbye.
And thank you very much, Robin, for being a great host today.
Great.